All right, welcome to our first online lesson, and we are going to be doing chapter 6.1 together. I will show you on another video on how to access your book online and some of the resources your book has online. It will be a little different because mine is going to be the teacher, but again, with anything, just explore, click around. There's also a phone number for the book, and you can call them and ask them for help for any of these needs that you may have. So we're going to be doing 6.1. 6.1 is going to be talking about exponential functions, and we're going to talk about the key features. So again, we're starting on a new topic, but some of the stuff that we've done in the past is going to be similar. For the first one, we are going to talk about this function. So I'm going to write in function notation, which is 2 to the x. Notice our exponent, or our variable, is the exponent. That's the first time that we've ever had a variable up there in the exponent. So like we've always talked about, when all else fails, we can make an x and y chart, which is what we're going to do to explore this, just to show it in the beginning. But we should start to realize some patterns throughout this chapter. As we get better at these, we should start to figure out what this thing is going to look like, how it's going to be behave and move, and so that's what our job is for this section. I'm actually going to make that a little lower. So here we go. I put a 0 in. You should know the rule. Anything to the 0 power is 1. So this would be 2 to the 0 power, and that would kick out a 1. So 2 to the 0 power is 1. So my first order pair is 0 and up 1. So it's right here. And we're going to go to the positive side because it's the easier side in the beginning. So we're going to do 1. If I put in 1. And 2 to the first power is just a 2. Go over 1. There we go. Now this thing is going to start to jump here in a second because now I'm working powers. I'm rocking powers. So 2 to the second power, be careful on this. For this one, it wouldn't trick you up, but 2 times 2, because this means you have 2 this many times. So 2 times 2 is 4. So 2, now not just a 2, 3, 4, we're going up double what we did last time. We went over 1, up 1. This time we went over 1, but now up 2. Watch what happens with this. If we put 2 to the third power, that really means 2 times 2 times 2, which 2 times 2 is 4, times another 2 is 8. So now we went over only 1, but now we're going up 4 from this point right here, or 8 total. 1. So 1, 2, 3, 4, 5, 6, 7, 8. Now this jump was over 1, up 1, over 2. This one is now over 1, and we went up 4. Right? Hopefully you're starting to see a little pattern, and you'll notice that this thing is starting to curve, and it's going to jump. It's going to skyrocket here very soon. So that's the right side, and that's what it's going to kind of look like. So I'm going to erase this and start on my left side. What would happen if I started doing x's as a negative? And we've talked about this recently, but this is definitely an old skill. What the heck does it mean if I take 2 to the negative 1 power? We talked about anytime you have a negative power, whatever it belongs to just goes to the denominator. So remember, this would be like this, and so this would send this down. Since there's nothing left up top, we'd put a 1. This one right here is not flipping up to the top. This is not a reciprocal. This is going down to the bottom, and since there's nothing else left up there, we have to put a 1. But really, it just means 1/2. You can check this in your calculator. So now I'm going here. What happens if I do a negative 2? Well, all that does is it makes 2 to the negative 2 really become 1 over 2 to the second power. Remember, this just kicks it down. And then that becomes 1/4. So I get even closer to this. But what you're going to notice is even if I put a negative 10 in here, this just becomes 1 over 2 to the 10th power. Now, 2 to the 10th power is a massive number, and 1 over a massive number is going to be very small, but it's not going to ever be 0. So hopefully you're starting to pick up on what I'm putting down here. There's an asymptote right here where this thing will never ever touch, but it's going to chase it. Remember, it's going to keep getting in closer and closer and closer and closer and closer to it, so close that my pen cannot draw that. So that's the first thing. So notice the shape of it. This is what exponentials are always going to look like. Notice because I didn't have any, plus or minus back here. There's nothing back here. There's no pluses or minus here. There's no number up here in front of that. That's what we're going to talk about later on. This is the kind of the parent function of this one. Notice it started at 0, 1. All right, so what would happen if I did f of x equals 2 to the x plus 1? Well, now instead of starting at, make my x and y chart to help us through this. Instead of I put a 0 in, well, yes, 2 to the 0 power is still 1, but now I have 1 plus 1, which makes me start at 0, 2. So notice it got shifted up 1. The other thing you're going to notice is no matter what, this is always going to be some number, maybe microscopic, and I'm always adding 1 to it, which means this thing will never ever touch 1 or go below it. So that means my asymptote also moved up 1. That's what this thing back here does. Remember, it moves it vertically, remember, up and down, and up 1. It moves it the way I think, just like we've done in the past. Even if I put f of x equals 3x plus 1, it's still going to be very similar. Again, all else fails, make an x and y chart. If you put a 0 in here, 3 to 0 is going to be 1, and 1 plus 1 is going to be 2. So it's going to still have that same starting. But then when I put a 1 in here, 3 to the first is 3 plus 1 is 4. And that would be different than if I did the 2 right here. If this was a 2 instead of 3. All right? So that's kind of how that changes that. So same thing we've talked about in the past. This is going to vertically move this stuff. And there is going to be an asymptote that also moves. When you move it vertically, it moves up and down. What would happen if I had f of x equals 2 to the x minus 1? Well, remember, this is like in parentheses. And what have we talked about all year long that inside parentheses does? This is going to move it left and right, an opposite way, I think. So I would think this would move it to the left. So it's actually going to move it to the right 1. Which means all my ordered pairs, I'm going to do my original here. My original was 1, 0. Well, watch what happens now. I'm going to have to put, that's my original, is in red. If I put a 0 in, I kicked out a 1. Well, this time, I'm actually going to have to put in a 1 to kick out a 1. Because 1 minus 1, if I put a 2, 1 minus 1 gets me to 0. And then 2 to the 0 power equals the 1. So this time, this point right here moved to the right 1. That's what this says it would do. And then my curve is going to be very similar. All the points are just shifted. So the point that was, if I put a 1 in, remember I kicked out a 2. So, whoops. Back. This is the original. This is the f of x equals 2x function. I put a 1 and I kicked out a 2, which is right here. That point, I'm telling you, is going to be shifted to the right 1. So now it's going to be, you have to put a 2 in to kick out a 2. And if you check that, if you put a 2 in, 2 to the 2 minus 1 gets me to 2 to the first power, which is 2. So I put in a 2, and that's what kicked out my 2. This point moved over to the right 1. My asymptote is not going to move because it wasn't moved vertically, so it's still going to be at y equaling 0. It's all the stuff that we've talked about in the past is still going to ring true. And none of that is going to change. I don't know how to do my stuff. Hey, there it is. Sorry, I had to figure out where that record button was again, and I had to pause it. So we're going to do just a couple more of these and just kind of get familiar with some of the ways that they can look and behave. And again, hopefully what happens is the more we use this, the more familiar we get with it. So here we go. Number, doesn't matter if it's F or G, equals 5 times 1/2 x. Now we're going to notice what happens with this now being not a whole number, but being a fraction. And then we're also going to kind of see what this 5 does. And again, we're going to make a x and y chart. And when we're plugging in, you must use order of operations. So let's go ahead and get started with this. Let's for the 0. What happens if I do 0? Well, this would mean 5 1/2 to the 0 power. Well, anything to the 0 power is still going to kick out a 1. So this turns into a 1 because 1/2 to the 0 power has to be done first. So I get 5 times 1, which is a 5. Sorry about that. And then I'm going to try 1. Well, that would mean 5 times 1/2 to the first power. Do this first. Anything to the first power is itself, so that would turn into 5 times 1/2, which 5 times 1/2 is 2.5. Not the best number, but not terrible. And finally, let's do one more in the positive side. What if I did, whoa, switched it on you, a 2? Well, that would mean 5 times 1/2 to the second power. This right here would mean that you would have 1/2 times 1/2, which can turn into a 1/4. This would mean you'd have 5 times 1/4, old school, 5 over 1 times 1 over 4, 5/4, or 1.25. Well, that can be done kind of in calculator, but I was showing you by hand how to do all that because I don't want you to be afraid of those fractions. One of my big thing has been all years, stop being afraid of them. So we're gonna have to jump up here. 1, 2, 3, 4, 5, and then that's this one. 1, 2.5, 1. Remember, this is just a sketch, so 2.5 is going to be somewhere around here, and then if I kept going, 2 would be 1.25 just above here. So you're going to notice to start that curve, and again, it's starting to do that. Because no matter what, even if I put in a 10 here, that's going to make 5 times. This is going to be a very small number when I take 1/2 to the 10th power. It's going to be very small, but it's still going to be something. It'll not be 0. In order for it to be 0, this has to become 0, and there's not going to be a way for it to become 0. So it's going to keep coming through. And notice that makes sense because we didn't do anything. We didn't do a plus or a minus anything back here, which means the asymptote should still stay at 0, which it did. Here's my asymptote. And now let's go ahead and go on the negative side of this. If I put in a -1, remember that says it's going to say, hey, this really comes to here and this becomes here, meaning 1 to the -1 and 2 to the -1. This comes up while this is going down. So this is actually kind of like the reciprocal. And so this becomes a 2. This says you go up and you go down, which is a 2. 5 times 2 equals 10. So if I put a -1 in, I get 10. -1, 5, 6, 7, 8, 9, 10. It goes all the way up to here. And we're going to do one more. If I put in a -2, that would turn into 5 times 1/2 to the -2. This would become 1, and that 2 to -2. These guys, again, would switch places, and so you'd end up with 4 over 1, and then 5 times 4, which is 20. So -2, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And this thing would look like this. So you notice that because of this 1/2, it's now what we would call a. The other one's called a growth. And so we need to talk about some things. Our domain is going to be, does it ever stop going left? No. Does it ever stop going right? No. So it would be all reals. Our range, though, is only from here up, and it's not allowed to be 0, so y would have to be greater than 0 and not equal to. So domain, range, all that stuff, there's an asymptote here. These are the different things they could ask you about in these questions, and you should be able to answer them. All right? A couple more examples. What the heck happens if I have g to the x equals a -3? All right, like this. Now, actually, I should have read that different. This is not a -3. This is the opposite of 3 to the x power, which means order of operations, when I plug a 1 in, this becomes 3 to the first power, which is 3. But then I take the negative of that, which kicks out a -3. So you're going to notice what did this negative do? Just like it did in the past, it flipped it over the x-axis. So it's going to be 1, 1, 2, 3 down here. If I put a 0 in, it would become 3 to the 0, which is 1. But then that negative would still be there, so it would be a -1. Remember, it is power first, then this, because it is not -3x. That would be -3 to the x power. This is the opposite of 3 to the x. So these things right here are not the same. And that's what we're going over here. So this would be here, and this graph would start to look like that. You can finish it up with your x and y chart, but it would look like this. We're just covering what that negative would do. And finally, this will be the last one that I go over today. This is half of this section. We'll go over the next half. You will have homework on it. I'll probably either take a picture or something. It's going to be attached in Portal. There'll be directions, so make sure you're looking for that. I don't want to include in this video because I'm trying to keep this video short. So this is the first half of 6-1. We have 3x minus 4. We already talked about this a little bit. We should think that this is going to move it down for everything, including my asymptote, which is normally at 0. So 1, 2, 3, 4. I'm saying there's going to be an asymptote here. And let's make an x and y chart and see if that's true. If I put a 0 in, that would be 3 to the 0. So 3 to the 0 is 1. 1 minus 3, or 1 minus 4 would be -3, which is right here. If I put a 1 in, that would be 3 to the first power, which is 3. 3 minus 4, which would be -1. And if I put in a 2, if I put a 2 in, that would become a 9. 9 minus 4 would be 5. 2, 1, 2, 3, 4, 5. And there's this side. And then if I continued on the other side, -1 would turn that into a 1/3. A 1/3 minus 4 would be, so this one, let's do this. I should do this one. That would say, hey, you flip over. So this becomes this, which would be fractionalize 4 over 1. So I times that by 3, times that by 3. 12, 3, 11/3, which would be somewhere around here. And you would see this thing start to go like that. All right, this is the first video. Hope it worked out well. Be looking for me to go live on Tuesday to answer any questions, and I'll probably put some more videos on how to do this and tomorrow, but I wanted to get the lesson up so you knew what you were supposed to do. So just take the notes, take all this in, try to understand it. This is called exponential functions. You can look it up online. You can go to the book online and start clicking through videos. They have all kinds of things to help you there. So make sure you're using all the resources that we can, and stay safe and happy. And I hope you have a wonderful Monday on our first day of actually teaching.